Hello, everyone, and welcome. This is Professor Thayer with you, talking about our functions. So we had started last time with an introduction to the functions, and we looked at how to do the function calls. So today we are going to continue on our discussion of them. So do feel free to follow along if you like, and I'm just going to share my screen here so that you can watch along right with me. So let me go ahead and do this. So as you remember, we talked about the overview and how to define the functions. Today, we are going to focus on the scope of the variables. That is, where are the variables going to actually be able to be used? So that might seem like a funny question. I mean, if it's defined, you should be able to use it, right? Well, not exactly. Imagine if there was some kind of memory in your function about the previous calculation that you did. Suppose that when you used your square root button on your calculator, it was somehow affected by a calculation you ran last month. By now, surely you've forgotten you even ran it. And besides, if you're going to take the square root of 16, it should just be the square root of 16, right? Previous information shouldn't have any bearing on that at all. Well, that gives us the idea of the scope of variables, the idea that we may wish to throw out the value once the calculation is complete. So we will be taking a look at that for today. Scope of variables, where they can be used. So the scope of the variable refers to the location where the variable is available to be used. To use a variable, it must be defined. So that should be fairly obvious from our previous discussion. If you haven't defined x and you try to do x plus 5, go to the variable table and look it up. Oh, it's not there. You're not going to be able to use it. You have to define your variables. You cannot use a variable before it is defined. The value of the variable may change over the course of the execution of the program. And we're going to see this extensively when we work on looping, because the variable will be defined. And then as the loop progresses, that value may be changed each time we go through the loop. And finally, we need to keep track of the available variables and their values in the variable table. This is just a convenient way for us to write down what information we have available. Now, in Python, there isn't really a variable table per se in the way that humans would write it down. There's not actually like a table in there, but all of that information, of course, is stored in there, and Python can make access to that information, especially if your variables are not defined. And if that is the case, then you are going to hear a complaint from Python. And my slides are changing. So let's take a look at this example here and see if you can figure out what the problem is. Uh-oh, I see traceback variable is not yet defined. So that's actually my comment. X is not defined. This is the name error. The name error tells us about a variable. So the variable is called X and it is not available. So when we try to do x plus 2 and we haven't done anything before, which we can see because we've just restarted the shell here, you're going to get this error. So be sure to define your variable. So we can see that if I simply just define x equals 3, then when I try to do x plus 2, now of course x is already defined and the problem goes away and we get our answer of 5 without any further ado. So we will be doing the variable table and keeping track of those values. And this will become increasingly important, especially in the upcoming weeks when we start doing if blocks and we start doing looping, all these things. It will be very important for us to be able to keep track of the value of the variables. So whenever you have an equal sign, so x equals 3, this is defining a variable. So that the variable table will now have a variable called x. So the first time that it gets defined, we'll create that variable in the variable table space. So now we have an x in our variable table, and its value would also be stored, which in this case is 3. So when Python is running, if we're trying to do something such as x plus 2, it will go to the table and it will say, oh, what's x? So it goes and searches through and says, oh, there it is. Let me pull the corresponding value for that. So it takes 3 and it substitutes 3 into x. and adds it to the 2. This is much like what you would be doing in an algebra class. You've probably done those exercises where you have lots of different variables and you need to substitute the values into those variables, and Python is doing exactly the same thing. Now suppose as you progress that x gets a new variable, new value. So we have x equals 4 now. It used to be 3. So now we are going to go to the variable table. It's not new, so we don't need to add it to the variable table because it's already here. But we check the value and we notice that the value is now updated. So we're going to cross off the 3 and replace it with the 4. And then when we do x plus 2, Python will go to the variable table and say, what's the value of x? Oh, it's 4. And so then it will substitute 4 in and we get x plus 2 now being equal to 6 as opposed to the 5, which was equal to above because the value of x was different. That brings us to the concept of the local versus the global variables. The local variables of a function are its parameters and any variables defined inside of that function. The region of validity or the scope of that variable will be inside the function. Local variables act like scratch paper for a function. When the function call is over, they disappear. So getting back to that idea about if you're going to use the square root button on your calculator, I mean, you just reliably want it to compute the square root of the thing you just told it, right? We don't want it to remember anything about square rooting last night, yesterday, 2 seconds ago. If you do 8 and press the square root button, you expect it's going to calculate the square root of 8 with no strings attached, no other influences. The way that this works is it has code that will flush out the values of all of the variables as soon as your function is over, guaranteeing that the next time you try to use it, that there won't be any lingering values stuck in your function that would possibly make your function come out wrong. And so that is the idea of local variables. That means that the region of validity of the local variable is only inside the function body. It only works when the function is running, and when the function is over, then the variable is gone forever. So you might say, well, how do we get it out? Well, we can do things like print and return the values the functions produce before the function closes. So this is how the local variables act like scratch paper for the function. It will throw it away and you don't have to see it anymore. And then it will keep your definitions of your function nice and clean. Local variables. Local because it's only working inside the function. So here is a function down here. Let this function be def double of number. So the name of the function is double and it's taking a number as an input. So all the parameters are always going to be local variables. That's just the definition. So here it is, it's called number. It's an input parameter, which we recognize because it's inside the parentheses and it's in our definition line. And so number is a local variable. Now we also have this variable called result. Result equals number plus number. So result also was a local variable because it is defined inside the function. So number is one because it's a parameter. So number is both a local variable and a parameter. And result is a local variable defined in the function. So we will then do number plus number, and here we are going to return the result, which will be that answer of doubling the number. In contrast, the global variables are defined outside of any function. They can be found in what we call main. And so up to this point, we've only been programming in main. We haven't been using anything that's inside the functions yet. So those are all global variables. They may be looked up, but not assigned from within a function. That's mostly true. That's the default behavior. There is a way to override it. For now, I'd like you to work with it like this, but as you get closer to doing your projects, I will be happy to tell you a little bit more detail about that. But for now, I want you to just leave them untouched and just use it like it is. You can try to assign a global variable from within a function that will instead create a local variable with the same name. This phenomenon of having two variables in the same program that which seems like it should be impossible, actually will work in Python, and that is because of the scope. One is defined in main, and one of them is defined in the function. And so when you have this situation, it is called shadowing. Local variables shadow global variables when they have the same name. Here's a little example of that. Here's a definition of some function f, and we have an x equals 4 inside this function, and then we're going to do some printing here. Notice that we also have an x out in main. This is before we get to the function. And so there are two copies of x. There's x equals 3 and there's x equals 4. So does x equal 4 overwrite x equals 3? No, it does not, because the x equals 4 is inside the function. So that is a local copy which will not be affected by the global copy. There will be two copies, each of having the same name. So you have x in main and x in 4, x inside the function. Another way of saying it is that the variable is uniquely defined within its specific scope. Global variables should be used very sparingly. When a function depends on a value, it should generally be passed as an argument to the function. That is, when you do your function call, you typically want to pass that as an argument, so that you're doing that instead of trying to make use of the global variables. Global variables are for program-wide parameters that would be tedious to pass to all functions. So for example, if you are coding up some kind of a game, maybe you want to keep track of the total number of points you have won. That would be a great example of something that you might store as a global variable. The global variable passed to a function's local variable does not need to have the same name. So let's just take a look at these little snippets of code here. Here we have def of greet. It will take name, and we have a local variable so that so happens to be the same as a global variable. So notice that there's also this variable out here in main called name that is associated with Professor Thayer. And now we're going to call this function greet of name. And so we have name out in main, and there is an implicit variable assignment to the local copy, which is shadowing name in main, that will then take on the value that we have sent up for it, which happens to be, it's me. It will, so it will greet me. Now, in contrast, let's take a look at a situation that does not have shadowing. So the reason why this is shadowing is because we have name defined as a parameter, which is the local variable inside the function, and there's also name available in main. So in this case, we have simply just changed the name of main to x. And also this right here, hello x, is going to have that. So what we're going to do then is we're going to call it. So do you notice that there's no global versus local problem here, because here we have name, and name does not appear anywhere inside the function. If you are going to be working with functions that are going to make use of information that's getting passed in like this, it's fine to have the variables have distinct names, but sometimes it's actually helpful to allow shadowing to happen so that you can remember the values of the things you have sent in. So I'd like to just take you through a couple of examples. We have some questions here, as you can see. And this is a little game that we used to play in my childhood. Maybe you've played this one too. We used to play back in the days with pencil and paper. You'd ask your friends to name some animals. What's the name of an instrument, right? And then you'd write it down, and those would get substituted into some story. But the person who is giving the information, naming the animal and so on, doesn't know what the story is. And then your playmate would then read it back to you, substituting those information into the story, which sometimes made all kinds of nonsensical things, and we always had a good laugh about it. So Python can do the same thing. Maybe you've played this game, but even if you haven't, I hope that this is a little bit of a fun way to take a look at this. So here we have our function, def of madlib. It's going to take animal, instrument, another animal, and obstacle. Here's our signature, and it's going to substitute words into the nursery rhyme, hey diddle diddle, which we can see has all these substitutions in it. So we've set up some values for these things to substitute in. We've chosen an animal, an instrument, another animal, and an obstacle of a mountain. And then we're going to do our Mad Libs function call to find out what our story is. All right, so questions I have for you. What are the parameters of the Mad Lib function? What are the arguments of the function call? What are the global variables? What are the local variables? And what will the output of the program be? So let's take this one piece at a time. The first thing we're interested in finding out is what are the parameters of the Mad Lib function? So that's easy to answer. We're simply going to look inside the parentheses in the definition line to obtain our parameters. The number of parameters could be anything. It could be 0 parameters, it could be 1 input parameter, or it could be many input parameters. This one happens to have 4. The next thing we want to look at is what are the arguments of the function call. So that means we need to find the function call. That's right down here, Mad Libs of animals, animal 2, musical, animal, and the thing that they're going to need to jump over, the obstacle. And so those will be sent up and then accessed as we move through the code. These are the arguments which are found in the location where the function call occurs. Notice that the number of these must also match to the number of input parameters that are being shown here. If there's a mismatch, Python will cause an error and let you know that they don't match. What are the global variables? So remember that the global variables are going to be the ones that are defined out in main. So here we have animal, musical, animal 2, and the obstruction or the obstacle defined right here. And so these are the variables that we have available in main. So these are, in fact, the answer to this question. Now, the next thing we want to know are what are the local variables? Now, do you remember we said that the input parameters are always local variables? The local variables is going to be the conjunction of the set of inputs and also any variables that are defined inside of the program. So we have 4 inputs here. So animal, instrument, animal 2, and obstacle are all examples, and move is a variable which is defined in the body of the function, which is going to also be included in our local variable list. Now, the next thing we need to do is we need to try to run that code in our head. What is the output going to be? This is an important thing to get in the habit of doing because we always want to make sure that the code we write has the anticipated output. So what will the output be? We can, of course, just run it, but let's just take a look. Now, here's our definition of animal, musical, animal 2, and obstacle. They have these strings. Here is our function call to our Mad Lib function. And so, oh, this is interesting. Mad Lib will first send up the value of animal 2, which is squirrel, to animal. Okay, so remember that there is going to be an implicit variable assignment as we are working through the definition line. So here we see this right in action. We also see that it's not necessary for these two to have the same name in order for this handoff to work. Remember that it's in fact sending the value that this variable is equal to. So it's not in fact actually going to match to see if animal and animal 2 are the same or not. Really, it just sends the value, and animal 2 happens to be squirrel. So it will happily send the value of the string squirrel to animal right here, and then it will get that, that value. So if we proceed then on down, musical will be assigned to instrument, and animal, just plain animal, will be assigned to animal 2, and we will have obs be assigned to obstacle. So we'll simply just fill in these values based on this. and it will send them up. And again, notice that it has gone out of order because animal 2 will transfer to animal, but animal will transfer to animal 2 because of the order that they are in here. So they're not actually matched up to be identical. And some of them are in fact not the same either. We have musical will go to instrument and obstacle will go to obstacle. So there's all these different combinations that are all possible. So we substitute in those values, and then we see that we have move equals tap dance, right? So that's going to need to be substituted in. But now we've filled out our variable table and we know what everything is equal to. So we can go ahead and start printing. Hey diddle diddle, the. Now it checks to see what the value of animal was, which actually came from this variable here, which got the value when we had animal 2. So animal 2 is squirrel. So this is why we get the squirrel and the, and now we have to do our next substitution, instrument, which had been substituted from instrument, which is great, and instrument had been receiving the information from musical, which so happened to be violin. So we'll now substitute in violin here. And so we continue. The animal 2, what does animal 2 equal to? Well, animal 2 is equal, animal 2 here is equal to this animal here, which is this animal, which is mouse. So it says the mouse tap, okay, tap dance came from move, right? Tap dance over, and what was the obstacle? That was sent up in OBST, and OBST is then assigned to mountain, so mountain, that value will be sent to obstacle, which then fills in the obstacle name right here. So it is basically a complex exercise in variable substitution. All right, so that works. And that is going to conclude our lecture for the second day of our discussion on functions. We look forward to seeing you next time. Bye-bye.